Yo, what's up guys? Today we're back in the shop working on the 632 out the Nova. Still trying to find the smoking problem, so stay tuned. We're going to check the cylinder bore and piston diameter, see if we find anything. The first thing I'm going to do is check the calibration on my digital calibers using a 1-inch standard. I'll put a description in the video showing you guys how to calibrate your digital calibers. The caliber is reading about 1,000 out of calibration, so I'm going to zero it out and check it again. Now it's set right at 1 inch, so it's calibrated and ready for use. The cylinder bore on this engine is 4.615, so we get the 4 to 5 inch outside micrometer to use for this job. We're going to check the calibration on it using a 4-inch standard. I typically don't check the calibration on my tools for every use, but for the purposes of this video, I'm going to go through this exercise, show you guys how I do it. I'm going to get it close by using a thimble, but once I get it close, I use the ratchet to tighten it down on our standard. You always want to tighten with the ratchet to make sure you have consistent force on your part being measured. The reading is 4 inches, so this tells us that our micrometer is still calibrated correctly, so there's no need to make an adjustment. I give you guys a little bonus tip. If the micrometer was out of calibration, we would use the spanner wrench that comes with the set, put it in the hole, and zero out the micrometer. Like and subscribe to the page if that was useful to you. Now we're going to set the caliber to the cylinder bore diameter of 4.165, locking in place, so we can use this to set the bore dial gauge close to zero. I don't use the digital calibers to get in my final measurements, but I do use it to get me close. These calibers are not really designed to measure down to the thousandths. That's why it's taking me a little time to get it set to the number I want. When I finally get it set, you'll see here I'm locking it in place to our 4.615 number. Locking it in place so it don't move on you and throw something off and make you have to go through this process again. Next, we're going to set up our dial bore gauge. This is actually the actual tool we're going to use to measure the cylinder bores. Using the digital caliber, we're going to set the dial bore gauge close to zero. I appreciate you guys tuning in to this channel. If you like what you see, please give me a like and share for the page. This is more of a racing page, but I do a couple of these videos to show some of the behind the scenes things that have to take place and things we do to allow ourselves to go racing. Next, we're going to set the outside micrometer to 4.165, the cylinder bore diameter, lock it in place, and tape it to a piece of wood to use it to set our bore dial gauge to 0. A lot of times I'll just put my micrometer inside the vise, but since the vise is on the other side of the shop and I already have my camera and everything set up, we'll just use this piece of wood. It works just as good. What I'm doing here is moving the face on the gauge to 0 it out and locking it in place. Now that we have our dial bore gauge set up, we'll move over to the engine and start checking the cylinder bores. First thing we're going to do is clean all the cylinders to make sure we don't have any trash that could throw our numbers off. We're going to check the cylinders in 2 directions, the thrust and the axle. We're going to check the top, middle, and bottom in each direction, so we'll have a total of 6 readings per cylinder. The gauge is zeroed out on the top reading on the thrust side, so that's telling us our bore is 4.165 like it should be. The reading is zeroed out in the middle and it's zeroed out at the bottom. Now we're going to check it on the actual side, top, middle, and bottom. We see a 1/2 thousandths at the top, so the cylinder bore is 4.1645. Same reading in the middle, and the same reading at the bottom. It's typical to see more wear on the thrust side because of the rotation of the crank causing piston rock in the cylinders. We found all 8 cylinders to be within tolerance, so now we're going to move on and check the piston diameters. The pistons are supposed to be 4.608 in diameter, so we're going to use the outside micrometer to verify the numbers. The pistons are within tolerance, measuring to be 4.6078. So both the cylinder bore and piston diameters checked out to be within tolerance. Alright guys, so we just finished checking the cylinder bores. It's supposed to be 4.615. All of them 4.615 within a 1/2 thou. One of them may be 1/1000 off on the thrust side. The piston is supposed to be 4.608. They measure 4.67677. So we don't have a problem there. So I figured we wouldn't find anything, but we this far into it, decided to go ahead and check. Guys, keep following the page. I'm still going to try to find the smoke.